So here we have a function x raised to the power of n minus a raised to the power of n divided by x minus a. So we have to find its limiting value when x approaches 1. So first thing first, we will be substituting for the value of x. So that would give us a raised to the power of n minus a raised to the power of n divided by a minus a. So this is giving us an indeterminate form. So we have 0 in both the numerator and the denominator. So we have to look for a different way to find the limiting value of the given function. So here, in order to find the limiting value, what we're going to do, we're going to use the definition that the limit of a function fx when x approaches a is said to exist if the limiting value of x approaching a of fx is equals to the limiting value of x when it approaches a from the right hand side. So we're going to use this particular definition. So let us assume that our limit x approaches a positive. That means it's approaching a from the right hand side. X raised to the power of n minus a raised to the power of n divided by x minus a. So this can be written as limit h going to 0. So we have x will get replaced by a plus h raised to the power of n minus a raised to the power of n divided by x minus a. Now considering the fact that the absolute value of h is lesser than the absolute value of a, so what we can do, we can rewrite the binomial as limit h approaches 0. So we factor out a from the binomial, so that will leave us with 1 plus h over a raised to the power of n minus a raised to the power of n divided by, so here I have made a mistake here. So what we need to do, we need to replace this x by a plus h. So the a and e will get cancelled out, leaving us with h in the denominator. Now what we're going to do, well, we're going to apply the binomial theorem for any given index n. So we have 1 plus x raised to the power of n, where n is any index. So this can be expanded as 1 plus nx plus n minus 1 over 2 factorial times x squared and the rest of the higher order terms. So let us apply that. So this will give us the limiting value of h approaching 0. Now what I'm going to do, I'm going to take a raised to the power of n as the common factor and expand the first binomial. So that will give us 1 plus n x. So our x here is h over a plus n times n minus 1 over 2 factorial, which is simply 2, times h over a whole square plus rest of the term and the final term, which is negative a raised to the power of n. Since we have already taken a raised to the power of n as the common factor, so that leaves us with negative 1 divided by h. So the 1 and 1 gets cancelled out. So positive 1 and negative 1 cancels out each other. Now we have limit h approaching 0. So along with a raised to the power n as the common factor, we are also going to pull out h. So that leaves us with n over a plus n times n minus 1 over 2. So we have pulled out 1h. So 1h will be remaining, divided by a squared plus rest of the remaining terms divided by h. So we finally cancel out the h from both the numerator and the denominator. Then we apply the limiting value of h, so that will leave us with a raised to the power of n plus n over a plus n times n minus 1 over 2 times 0 over a squared. So that means each of the term are going to have an h. So that means all the higher order terms will be equals to 0. So we are left with only the first term. So let us combine the first term. So we have n a raised to the power of n minus 1. So this is the limiting value of our function x raised to the power of n minus a raised to the power of n divided by x minus a. So this is n a raised to the power of n minus 1. So this is a standard result that we are going to use. Let's do a numerical. So let's say we have to determine the limiting value of x approaching 2. We have x raised to the power of 10 minus 1024 divided by x minus 2. So this can be rewritten as limit x approaching 2. We have x raised to the power of 10. So when we take the factors of 1024, we see that 2 raised to the power 10 is equivalent to 1024 divided by x minus 2. So now here we have the value of a, which is equals to 2, and the value of n, which is equals to 10. So that means we have n, which is 10, times a, which is 2, raised to the power of n minus 1. So we have 10 times 2 raised to the power of 9. 2 raised to the power of 9 is 512. So 512 multiplied to 10 give us 5120. So this is going to be the limiting value of the given function when x approaches 2.